Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my lecture on our laboratory subject of IT 125, Systems Integration and Architecture 1. Let us learn loop structures in PHP programming language. Loop structures command the CPU to do repetitive tasks. Number 1. For statement. There are two syntaxes of for statement. The first syntax, we write the keyword for followed by parentheses. Inside the parentheses, we put an initialization statement followed by semicolon. Next, we place the conditional expression followed by semicolon. Next, we place the increment or decrement statement, then provide one statement or command to be executed by the CPU repeatedly. For example, this for loop has sentinel variable $I initialized to 1. The condition $I less than or equal to 5 and the increment statement $I plus plus. This loop will repeat 5 times from 1 to 5, changing values for the sentinel $I variable. The second syntax has a block statement enclosed by curly braces. You can place more than one statement inside the block statement. For example, this for loop has sentinel variable $I initialized to 5. The condition $I greater than or equal to 1 and the decrement statement $I minus minus. This loop will repeat 5 times from 5 down to 1, changing values for the sentinel variable $I. The for statement performs repetition when the condition is true. It will stop repeating when the condition is false. Number 2. While statement. The syntax, we write the keyword while followed by a conditional expression enclosed by parentheses. Provide the statements or commands to be executed by the CPU repeatedly inside the statement block or block statement. The while statement performs repetition when the condition is true. It will stop repeating when the condition is false. For example, $I is initialized to 1. The condition for the while is $I less than or equal to 5. Since the value of the $I is initialized to 1, 1 less than or equal to 5 is true, therefore, it will enter the body of the loop and then it will repeat for the first repetition. This while loop will repeat from 1 to 5 or 5 times. When the value of I is greater than 5, that's the time that the condition is false and the while loop statement will stop repeating. Number 3. Do while statement. The do while is similar to the while statement. The difference is that the condition is placed at the end. The syntax, we write the keyword do. Next, provide the statements or commands to be executed by the CPU repeatedly inside the block statement. Next, we write the keyword while followed by a conditional expression enclosed by parentheses. We must place semicolon at the end of the while condition. The do while statement performs repetition when the condition is true. It will stop repeating when the condition is false. For example, this do while statement will repeat 5 times from 1 to 5. By the time that the value of the variable I is 6 and above, the condition will become false. And that's the time that it will stop repeating the do while loop statement. Escaping from loops with break statement. The break statement terminates the loop or switch statement and transfers execution to the statement immediately following the loop or the switch statement. The break statement will stop repeating the loop. For example, this for loop repeats 3 times from 1, 2, and then 3. There is a conditional expression if statement inside the block statement of the for loop. And when the condition $i is equal to 3 is true, it will run the break command, and what will happen is that it will jump from this line and then move after the for loop block statement, and it will end or stop repeating the for loop. And the output of this for loop statement, it will display 1 and 2. When that break command is run by the CPU, there are statements or one statement that are skipped. Like for example, the echo command will not anymore be run by the CPU when the break is executed by the CPU. Skipping loop iterations with the continue statement. The continue statement causes the loop to skip the remainder of its body and immediately retest its condition prior to reiterating. For example, this for loop statement will repeat 5 times. The condition inside the body of the for loop, if $i is equal to 3, during the third repetition is true, the CPU will execute the continue statement. When the CPU executes the continue statement, it simply jumps to the condition or to the body or in the parenthesis of the for loop. Therefore, the echo statement will be skipped by the CPU, and it will increment the value of the $i, and then it will test the condition. Computers are very good doing computation repeatedly. Let us look at this example taken from the laboratory hands-on activity number 4, sum of series. To set up a loop statement to add fractions starting from 1/3 to 3/5 until to the fraction 97 all over 99, we observe that the numerator of the first fraction begins at 1, and then the denominator begins at 3. The last fraction has a numerator that ends 97, and the denominator ends at 99. Knowing this information, we set up the for loop statement having 2 sentinel variables, one for the numerator and another for the denominator. The sentinel variable $numerator will be initialized to 1 because of the starting numerator of the first fraction starts at 1. The second sentinel variable $denominator starts or initialized to 3 because the first fraction has a starting denominator of 3. We observe that the numerator has an interval to the next numerator fraction of the next of the series. From 1, it will become 3. From 3, it will become 5. And then there is a interval of 2. Likewise, to the denominator, the interval between 2 fractions is 2. From 3, it becomes 5. From 5, it becomes 7. And then therefore, there is a denominator of 2. Therefore, our increment statement will be $numerator plus or equals to 2 and $denominator plus or equal to 2. The condition that we need to set up is we can test if the dollar numerator is less than or equal to 97, the last numerator of the last fraction. Or we can also test the denominator if it is less than or equal to 99. It also works. The body of the for loop, we simply set up the computation of the fraction by dividing the numerator by the denominator and then add it together. And we need first to declare a variable $sum initialized to 0. It is very important that we need to initialize to 0, not 1, so that it will calculate the sum of these fractions. When we run this, the output will be the sum of the series is 45.12. The PHP hands-on activity number 4, when we look at the HTML file, inside the body tag, we can see a form tag that contains a submit button. And then there is no input of text or values. The input is by clicking the submit button. The compute.php, as we saw previously in our lecture, contains the following code that will calculate the sum of a series using a for loop. Let us run in actual web browser. And this is the user interface of the hands-on activity number 4. If I click the submit button, the server CPU runs the compute.php and then iterate the for loop statement and calculate the sum, and then the result is 45.12. Here is your assignment. On page 12 of the laboratory manual, solve the laboratory hands-on exercise number 3. If you are assigned set A, then solve set A. Otherwise, solve set B. I posted your laboratory hands-on exercise number 3 in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.